Okay, you ready? Notes are out, right?
Yeah.
Okay. You are going to today do this. You're going to try to find the inverse of a function. Inverse. Before I start, though, I want to say this to anybody that's listening to this recording. Your assignment today for 1-9 is off on the calendar. So when you look at Wednesday, it's Wednesday today, right? Look at Wednesday. That is not true. That was yesterday. I copied and pasted it, and I messed up. So where do you get Wednesday's assignment?
Thursday.
You got to look at Thursday. Bring it over to Wednesday, and that's today's assignment. Okay? So next Monday is actually tomorrow's assignment. Now here's the deal. If you look at next Monday's assignment, it says finish 1.9. So today's lesson, we'll do it today. We'll finish it tomorrow in class. Here's the deal. Everything is a short class tomorrow except you guys. You guys, I think, are you're 45 minutes, so you're a little shorter. But here's the deal. It's nice that we're ending the week on a short class and we don't have anything to really talk about. Today we're going to talk about it. You're going to do what you can tonight. Come back tomorrow, finish it up in class. Ask questions. Okay, you ready? Inverse functions. Informally, inverse functions are those that undo each other. Okay? So if I go like this, okay, you try it. If I go like this, I start you with a number 10. And I say, okay, I'm going to do something to 10. I'm going to add 5 to 10. Okay, now I'm at 15. What if I want to go back to 10? What undoes addition? Subtraction. So basically, 10 plus 5 is 15. Okay, but if I go 10 plus 5 minus 5, I'm right back where? I'm right back at 10. So when I say undo, I mean, how do I undo addition? Subtraction. How do I undo multiplication? Division. How do I undo squaring? Square root. Okay. So that's kind of what inverse, you got to think that way, what an inverse does. Okay, so down here I go like this. What function would serve to undo this function? How do you undo that function? Now what I'm saying is this. You put in an x, you get out a y. Okay, so they did it. They put in what? 1. And then when they put it in, they got out 3. They put in 2, they got out 6. They put in 3, they got out 9. Okay? How do I undo that? What I mean by that is, I put in 1, I got out 3. How do I put in 3 and get out 1? How do I put in 2, I got out 6. How do I put in 6 and get out 2? There's another function that would do that. It's called the inverse function. So I'll go like this. I'll call the inverse g of x. This is the inverse. Okay? So here's where you're at. You put in 1, you got out 3. You put in 2, you got out 6. 3 got out 9. I want to go this way. Put in 3, I'm going to go different color. Put in 3, get out 1. Put in 6, get out 2. Put in 9, get out 3. Is there a function that would do that for you? 1/3 x. Good? Is there another way I could have wrote it? Just curious. X over 3, yes. And I really thought you guys would say x divided by 3. Because why? What undoes multiplication? Division. I thought you'd say x divided by 3 would work. This is the same thing as this, okay? Does this really work? If you put in 3, 3 goes in. Do you get the 1? Yeah. If you put in 6, do you get the 2? Yes. And if you put in 9, do you get back to 3? Yeah.
No. Do you know what set of keys I could use to get back in this?
I want to say it's this. Yeah, I think it's this. Yeah. Okay, so guys, this is called the what function? Inverse function, right there. Okay, now just quick, the inverse function, if you look at it, if you look at the ordered pairs that actually work, all right, so what works in this function? If I put in 3, I get out what? If I put in 6, I get out 2. If I put in 9, I get out 3. What do you notice about the function and the inverse function? Look at the ordered pairs. 1, 3, 3, 1, 2, 6, 6, 2. Are you guys looking? What do you notice? They're not opposite. They're reversed. X's and Y's get reversed. If you have an XY in your function, in the inverse function, it will be reversed 3, 1. You get that? That's really, really important to you because you're going to be graphing your inverse today. And if I know 3, 1 is on my function, what do I know about my inverse? Well, I said that backwards, sorry. If I know 1, 3 is on my function, I should know 3, 1 is on my inverse, okay? All right, let's move. Let's keep moving. Okay, here we go. If f of x and g of x are inverse functions, then this will be true, okay? F of g of x and g of f of x will give us what? What will the answer be every time? X. Because what they're saying is this, whenever you put into one function, you get out an answer, but if you put the answer in the other function, you get out what you started with. Okay, x. You started with x. So you have to do this, and the word they're going to use for you today is this. You might want to copy this part down. You will have to do this. And the word is verify. Verify that this is going to work. If you took the composite and the other composite and you get x and x, you know they are inverses. Okay, so here's your first example. Show that this, f of x equals 3x plus 2, and this, g of x equals x minus 2 over 3, are truly inverses. What are you going to do? How do you prove it? You do the two composites, okay? So why don't you try start that? Because this is actually yesterday's lesson. This is exactly what I did with you yesterday. Prove to me that this is x. And then prove this one, g of f of x. Prove it's x also. Oops, I don't need to put that x in. Okay? Now, if yesterday's assignment went well for you, this is pretty easy. Oh, where's your stuff? Okay, let's go. You guys, this stuff is yesterday's assignment. You didn't hardly ask me any questions. G of x is what?
X minus 2 over 3.
Thank you. X minus 2 over 3. Okay. And then I said yesterday, the inside function gets put into the outside function. So this has to go into f. F is straight up here, guys. It's right there. It's 3 times x plus what? 2. What are you going to put in for the variable x?
X minus 2 over 3.
X minus 2 over 3. Now it comes down to Algebra 1. Did you learn your Algebra 1 skills? How do you simplify that?
The 3's cancel out.
Okay, because,
It's distributed through.
well,
3 over 1.
it's 3 over 1 times this over this. It's just two fractions. When you multiply two fractions, cancel what you can. This 3 are the same number. So you end up with what? X minus 2 plus 2 is x. And remember, when you started, any number goes in. X goes in, you get an answer. You take your answer, you put it in your inverse, and out comes x, the number you started with. That's what you have to get every time, x. Okay, but wait a minute. It's not good enough to prove it once. You got to prove it twice. Here's the other one. You have to prove that g of f of x is also x. Okay, so we're going to go g of f of x. F of x is what? 3x plus 2. Okay. And now, of course, this number is, you don't know what this number is. It could be 10, it could be 20. You're going to put it in g. But where's g? Right there. It's going to be the x number minus 2 over 3. And what are you putting in for x?
3x plus 2.
3x plus 2. There you go. So this gets put into your x, right? How would you show me work on this?
One of the twos, subtract.
Okay,
two
so you're saying the twos are gonna cancel out?
Yeah.
Okay, do you really need these grouping symbols?
No.
Is that multiplication?
No.
No, I put it there just to show you that all you're doing is putting a number inside this spot, okay? You don't need the parentheses, even though I put them there, you don't need them. Okay? All right, so what is this? On top you get what?
3x.
Just 3x. On the bottom you get 3, and this is just a fraction. 3 times x over 3 times 1. When you have multiplication over multiplication, cancel. What's the answer?
X.
X. There you go. It's done. Are you okay? Okay. Now, you know this x I keep talking about? This x is what you started with. You put in a number, you put it in your function, you got out an answer, you put your answer in your inverse, and you got out the same number you started with. So if I did that with you up here, can somebody out there, thank you, can somebody out there give me a point in function f? And I don't care what point, just give me any point.
1 negative
0, 2.
0, 2, okay. You guys agree? He starts with 0, right? He puts it in, 3 times 0 plus 2 is 2. So he gets 2. Then this answer, if this is the inverse, then he takes his answer, he puts it in his inverse function 2, and he's supposed to get back to where he started from. Does he get that?
Mhm.
2, take away 2, 0, 0 divided by 3, 0, and it works. So whatever you start with, you put it into your function, you put your answer in your inverse, you get what you started with, x. And that's what I was trying to say, it's just x, because x can be any number. Paul picked 0, I could have picked 5, you could have picked 10, whatever. Just it's always going to be x. Any questions with this? This is just proving, you're proving that they are truly inverses. And you will always do it when you see what word? Can you see it? What's that word? Verify. In your book, if it says verify, verify means do this, get x, do this, get x. And the most important thing to me on a test is what? Work. I could care less. You know what? If you guys just write f of g of x equals x, you get no credit. You got to show the work. Okay. All right. Next up. Oh, this is just a quick comment. It says notation. The inverse of f of x is written f to the negative 1 of x. So this is what? The inverse of this. Now, do you remember when I started class, I said f of x equals 3x. And then I think somebody out there said g of x, the inverse. The inverse of that is what?
X over 3.
Didn't we say x over 3? Okay. Well, instead of saying g of x is the inverse, here's what you do. You go, here's my function f of x. If that's truly my inverse, don't use g of x. Use the function notation. It would be f of x. How do I denote that that's the inverse?
-1.
Yeah, put the negative 1 there. That's it. Equals x over 3. So this is how you put the inverse in paper. Okay? All good there? That's all it was. Just telling you that. Okay, 1 to 1. You don't have any of these definitions on paper. I think I just wrote these for you. And I reversed the order here. I reversed the order, so you can just leave it as is. But I wanted to talk about 1 to 1 first. Okay? So what are 1 to 1 functions? It says this. Given a function f, any function, okay, each y value on the function corresponds to what?
1.
Exactly 1x value. Sounds like the definition of a function, right? The definition of a function says each x value gets exactly 1y. This says each y value gets exactly 1x value. So, so if this happens, it is said to be what? 1 to 1, which means the function f has what? An inverse. So for you to understand that, I'll draw you a picture. Okay, do you remember that this is the what function again?
Cubic.
That's cubic, okay. So, is there an inverse to this?
Yes.
How do you know?
Because the horizontal line, I guess.
You weren't supposed to look at that. It says each y value corresponds to what? Exactly one y value, or one x value. Here's the deal. You will do this test on every function just to see if it has an inverse. It basically says if you take 5 on the y-axis, this is a y value, does this y value get exactly 1x?
Yeah.
Go over, hit it, come straight down, you got 1x. This y value, -6, did it get 1x value? Yes. So what they do is they say there's a horizontal line test. The horizontal line test says if you hit the graph once, then what do you think happens?
There's an inverse.
The function has an inverse, exactly. So the horizontal line test is telling you if your function has an inverse. Okay? And I'll read that to you too. I just didn't think this was that important. I thought that one was important. This one is just telling you. A function f, so here's your function right here, okay, has an inverse function if and only if no horizontal line intersects the graph of f at more than 1 point. So if it hits it once, it has an inverse. If it hits it twice, what do you say?
No inverse.
No inverse. 3 times? No inverse, okay? Yeah.
So if it's linear or cubic, it always has an inverse.
Careful. Almost, but you almost have the truth. Isn't this linear? Isn't that linear?
Okay, well.
Does a horizontal line, yeah, but what I'm saying is, a horizontal line will hit a horizontal line all the time.
Yeah,
So this one has or does not have an inverse.
it doesn't.
It doesn't have an inverse.
Besides that.
Besides this, you're right. Did you even hear what he said? He said a linear function, other than this one. So if I draw a line like this, guys, does this have an inverse?
Mm-hmm.
Yes, it does. The horizontal line hits it how many times? Once. So every linear, cubic, right?
Sometimes quartered.
Oh, you know what? I should say cubic,
Not quartered.
because cubic functions can do this. So like if you got this kind of function right here, that can be that's a cubic function. Does this have an inverse?
No,
No.
I've never seen.
Look. 1, 2, 3. No, that doesn't. So let's just say linear. Linear works. Okay. So what doesn't have an inverse?
Parabola.
Parabolas. Yeah, look at this. There's your parabola. Okay, right there. Draw a horizontal line through it. You hit it what? 4. Maybe once. Right here. If I hit it once like that, guys, does that mean it has an inverse?
Don't draw a line there.
Well, I can, but you got to keep drawing, right? Boom, boom, boom. No inverse. Okay, so there's no inverse. This one, yes. This one, yes. How about this one?
No.
No. Okay. Good enough? You got it now?
Yep.
Okay, move on. All right. Your turn. Start doing this. Here's part A. We are going to graph the inverse function right now. How do you graph it? Well, we're going to do these 3. A, B, C. It's no fun graphing inverses, but it's not hard. Here's what you do. You graph the function first. So let's just do this. Graph the function right here. Identify 3 points on your graph. Now you have a little bit of room over there, just graph it. And by the way, which parent is this? Square root. It's your square root parent. If you know what your square root parent does, slide it whatever way. I'm not going to tell. Don't say. Just do it. there's the parent, correct? Jake, stay with me, guys. Come on. There's the parent. You know you're going to do what to the parents? Stretch it, compress it, reflect it. What? What are you going to do? Right 2. This is a horizontal shift right 2. So this parent would start where? Where?
2, 0.
2, 0. There you go. So it starts at 2, 0. Got it. Where would this one go?
1, 1, or 3, 1.
3, 1. Okay. Where would this go? This is 4, 2. This would go where?
6, 2.
6, 2. Got it. There. Okay. 6, 2. All right. So there is the graph of that. Now I'm going to erase the parent because I don't want to see the parent now. Okay. Boom. All right. Okay. So there you go. All right. Now. Here it says, using those 3 points, this is part B now, using those 3 points, go graph your what? What is this called? That's your inverse. Go graph it. You know what to do? What are you guys going to do?
F and G of X and G of F of X.
No? What? Plug in points? I don't have to.
Flip the points around.
Flip the points around. That's what we said in the very beginning. Whatever points are on your function, what's on the inverse function?
Opposite.
Just reverse it. So instead of 2, 0, you're going to have what?
0, 2.
0, 2. Instead of 3, 1. 1, 3. Instead of 6, 2. 2, 6. Yeah. That's all you had to do. That's why you don't really graph the inverse. You graph the function, then you reverse x and y, and then you just graph the inverse. So where is 0, 2?
0, 2.
Up 2. Where's 1, 3? Well, right 1, up 3. Where's 2, 6? Right 2, up 4, 5, 6, I guess right here. So that'd be about here. There it goes. Okay.
Inverse is mirrored over y.
Yep, that's where we're going. So now, would you please do me a favor and graph this function y equals x? Just graph it on your paper somewhere. Now remember, y equals x is just linear. You could probably write it like this if you wanted, put it in slope-intercept. So it crosses the y-axis where? 0, there. Slope is what? 1 over 1, yeah. So 1 over 1 means over 1, up 1, right 1, up 1, right 1. And if you kept the pattern going, it kind of goes like this, doesn't it? So there goes your line y equals x. Anybody have any clue why I made you do that?
Reflection over that line.
That's the reflection line. That line is what, wherever your function lies, your inverse will be reflected right over y equals x. So if you look at it, guys, this point should be the same distance from there to there as this distance. And this distance with this distance. 6, 2. 6, 2 to here, and whatever this is, 2, 6 to here. So they're perfectly reflected over y equals x every time. So if you ever graph it and you go, wait a minute, this doesn't look right. It's not reflected over y equals x. Then you know you did it wrong. Okay? Does that make sense? It's a good, helpful hint is what I'm saying. All right? Any questions? Kyle, your hand's not up, right? Okay. Okay, here we go. Oh, no. Oh, this is bad. I took the time to write all the... It says, let's review the process described on page 96. And I forgot to save it, I guess, because last period I said don't save it. Okay, so here's the deal. How do you do this? We're going to find the inverse of a function algebraically, which means basically we have to show our work, okay? So, I'm going to have to write it out for you. You should probably write it with me. It's 1, 2, 3, 4, and 5, okay? Let's say this. I'll try to do this quicker. Use the horizontal line test to check if f of x has an inverse. This is the longest one I have to write, has an inverse. Period. Okay, well, do you guys know what you're looking at? Here, find the inverse of the function f of x. Do you know what you're looking at?
Yes. Parent shifted down 3.
It's the parent shifted down 3. That is the cubic function, so you should kind of know this. The cubic function goes like this, what I'm doing here, but it's down 3, so it's going to probably look like that, right? Negative 3 is here. All right. Use the horizontal line test to check. Does it hit it once? Yeah. I mean, it's pretty obvious. Once. So yes, this does have an inverse. So you checked it and it's good. So I'm going to just write the word good for number 1. Because if you check it and you go, wait a minute, it doesn't even have an inverse, then you're wasting your time trying to find the inverse. Okay? So step 1, check to see if it has an inverse. Step 2, now my instructions go a little quicker. It's replace. You just replace f of x with what? No, with y. Because f of x is y. So let's do that. Cross it out. Y equals x cubed minus 3. Good? Do you guys remember from last year? What's next? You want the inverse, right?
Switch x and y.
Yeah, because the inverse, all the ordered pairs are switched. So let's switch x and y. Okay, so this y becomes x. This x becomes y. Okay, then I'm going to say solve for what?
Y.
Solve for y. Okay. So let's do that. Everybody, switch your x and y. Now solve for y. Go.
Cube root of x
Right there.
plus 3.
Hunter. I know you're doing it in your head, but I want them to do it on the paper. I also want you to do it on the paper. Okay, there's my guess. You added 3 to both sides, you got x plus 3 equals y cubed. How do you get rid of the cube?
Cube root.
Cube root. Okay, so you do the cube root of both sides, right? Cube root of this. Cube root of this. Answer? Y equals the cube root of x plus 3. Is that good?
Yeah.
Okay, that's your inverse. You found your inverse, it's right there. Now, one last thing with your inverse, and that is replace y with
F of x.
function notation. How do we represent the inverse?
F of x negative 1.
F, raise it to the negative 1 of x. So you go down there now and you go like this. Okay, cross that y out. Let's just say this. There. That's function notation for the inverse. Okay. Step 5. This is the last thing you have to do. You will have to verify. Verify means prove what you found is truly the inverse. Well, how do I do that?
F of g of x.
Okay. But I'm not going to write f of g of x. I'm going to write f of the inverse of x. And what else?
Inverse of f.
The inverse of f of
F of x.
f of x. Yeah, there. Do those two things, and you've proven that you did it right. And what should you get each time you do it? X is the answer. Okay. Let's go. Okay, that is your inverse. Your function was what? I can't remember. X cubed minus 3. Okay. X cubed minus 3. And this one is right here. Okay. So here we go. And I hope you're ahead of me and not trailing me. You should be doing this. F of the inverse of f of x. Okay, there. And then you'll do this one. And you know, I hope you know, your answer is what? X. Okay. So what is the inverse? What's the inverse? What do I put in there? Cube root of x plus 3. Which now, the inverse goes into the function, like this. And the function is right there, so you'd have to put this number in for that x, and then cube it. So it's going to look like this. Right? In for x goes this number, cube root of x plus 3. Now, the algebra behind this is what?
Take away the cube.
Yeah, cube root, and a cube do what? Cancel out. What's left? X plus 3 minus 3 equals what? X. There you go. Don't take a shortcut on me. Don't go from here straight to X. You go from here straight to X. I don't care. I don't care if you can do that in your head. I care that you showed me this and this cancel out to get X. This plus this minus this is 0, then you get X, okay? Just prove it. Don't take shortcuts. Okay, next one. What do you put in for f of x? What's f of x?
X cubed minus 3.
And that goes in for the inverse, right? The inverse is right there. So you have to plug a number in for this number right here. Okay, so it becomes the cube root of whatever x is plus 3.
X cubed minus 3.
X cubed what? Okay. Now I could wrap it in parentheses, but do I really have to? No, because it wasn't multiplication. I could have got away with not even doing that. Okay. Okay, so here we go. Finish it up. It is. All right, inside, what do you get inside? X cubed inside. There you go. And then what? And here you got x. Did you prove it? You have it right. Yeah. That's all it is. If I told you to graph it, how would you graph it?
Reflected over y.
I wouldn't. I wouldn't.
Find 3 points.
X cubed minus, was it minus 1? Is that what it was?
Minus 3.
Minus 3? Okay. I would, if I were you, I'd take the parent, drop it 3, so you kind of know 0, 0 is where? 0 what?
Negative
Yep. And then you should know the parent goes over 1, up 1, right? And then left 1, down 1. So you should know those 3 points. What are they?
1, negative 2.
1, negative 2, yep.
Negative 4.
And what's this one?
Negative 1, negative 4.
-1, -4. Okay, so that is your parent. But you got to remember, this thing goes like this. Okay? Now, how do you graph the inverse? Switch the points. So where is 0, negative 3 going to be? Right here. Where's 1, negative 2 going to be? Negative 2, 1. Where's this one going to be?
Negative 4.
Yes. And you're basically going to get, oh, this will be kind of weird. This is going to go like this, guys. This one's going to go like this. See that? Because it's really a reflection over what? There you go. That's weird, but that's what it would look like. Anyways, that's the assignment. Do as much as you can tonight. when you get back tomorrow, finish in class with me, ask me any question you wanna ask me. I don't have much for tomorrow, okay? It's a 45-minute class tomorrow.
So we're gonna work on
I'm assuming you're gonna get most of the material. I think I'll probably give you a quick quiz on, transformation.
No, it's fine.
You should be good at transformation, by now.
I have a question. What's the point of that thing up there above
What thing?
thing above the projector?
That would be pre-smartphone.
Why didn't you take it down? You can,
Too much work. Well, they can't, why don't they take those? That's work, yeah.
well, you're like, it's not like more than.
Work is money, right?
It's like, you just have to get it on
They're not anywhere. That's true. It's just bugs.
We have something else 6.5 this classic, like last year.
Oh, you're just saying take it off?
Yeah.
Is it buggy that much?
What? I was wondering if something. How did like go away?
You want to still or land or all that stuff?
I don't know where that came from. NFG.
You're already
Well, we got walk up.
Mm-hmm. I'm in my room and he's running around the hall.
this lesson. Did you understand this lesson? You haven't looked at those ones? You sound good. Maddie, how do you feel about it?
Where do you get your assignment today, guys? What day are you gonna look at?
Thursdays.
Look at Thursday.